Okay, what if you could teach a machine one of the most human things we do, making a group decision? Well, that's exactly what we're diving into today, a wild experiment where an AI learned how to vote, and what it discovered might just change how you think about our own choices.
So let's kick things off with a question, a puzzle really. If you taught an AI how we vote, using all our different, sometimes complicated systems, which one would it find the easiest to learn, the simplest, the most natural? The answer? Well, it's not what you'd expect, and it tells us a ton about the systems we use every single day.
So how do you even figure that out? Well, some researchers set up this really cool digital classroom, but instead of teaching an AI how to vote for us, they used it as the student, a total blank slate, to see what it could teach us about our own methods of making choices together.
All right, so who's the student in this class? It's a neural network. You can just think of it as a type of AI built to be a sponge for information, designed to find patterns in data. Its only job was to look at thousands and thousands of election results and just learn to predict the winner based on the patterns it could find.
Okay, so what's on the syllabus for our AI student? Well, it was trained on 3 classic voting rules. The big ones from social choice theory. And you gotta know, each one has a totally different philosophy for how a group should pick a winner.
First up, you've got the plurality rule. Now, this is the one most of us know, right? It's super straightforward. Whoever gets the most number 1 votes wins. Simple. But it actually ignores a whole lot of information.
Next on the list is the Condorcet rule. This one is completely different. It's all about head-to-head battles. A Condorcet winner is the one candidate who, if you put them up against every other candidate one-on-one, would win every single time. Think of it like the undisputed champion of a round-robin tournament.
And then there's the third one, the Borda rule. With this one, you don't just pick your top choice. No, you rank all the candidates. Points get handed out based on that ranking. More points for being higher up, fewer for being lower down, and the candidate with the biggest score at the end wins.
Okay, so that's the setup. Here's how the experiment actually went down, step by step. First, the researchers generated thousands of fake elections. Then, they fed all that data to the AI, training it on just one of those voting rules at a time. And the final step was the big test. After all that training, could the AI actually predict the winner, using the rule it was supposed to have learned?
So the team runs all the tests. They're measuring how fast and how well the AI could get the hang of each system. And what they found was, well, it wasn't what a lot of people might have guessed. And folks, this is where it gets really interesting.
So, after all that, out of these 3 totally different ways to make a choice, which one did the AI, our neutral, unbiased student, find the most, well, natural? Which one just clicked?
Well, the answer was surprisingly clear. The AI was just better, way better, at learning the logic behind the Borda rule. It wasn't even close compared to plurality or Condorcet. And we're not talking about a small difference here. I mean, listen to what the researchers found, and I'm quoting here. The neural network mimics the Borda rule most closely, no matter which rule the network was previously trained on. Get that? Even when it was trained on the other rules, it still kind of drifted towards Borda. It's like Borda has this gravitational pull for an AI that's just trying to find a logical pattern.
So that begs the question, right? What is it about the Borda rule that made it so much easier for a machine to learn? Why did the AI find its patterns so compelling? Well, the secret sauce, it's all in the data.
Okay, here's the key thing to understand. Remember the plurality rule? It only cares about who you put at number 1. The Borda rule, though, uses every single piece of information on your ranked ballot. Your second, third, and fourth choices, they all matter. They all contribute to the final score. This table really breaks it down perfectly. Look at plurality. It just takes your number 1 pick and throws the rest of the data away. Condorcet, that's all about those one-on-one matchups. But Borda, look at Borda. It uses everything. Your entire ranking helps decide the outcome. For a machine that's built to find patterns, that richer, more complete data set creates a much stronger, clearer signal to learn from. There's just more to work with. Okay, so what's the big deal? What does this actually mean for us? Look, the goal here isn't to say Borda is the best system or that we should let robots vote for us. No. The real takeaway is something way more interesting.
So first off, let's be clear. This isn't about getting rid of human voters. Not at all. What this is about is using AI as a tool, giving us a whole new way to think about our voting systems. This idea of learnability. How hard is a system's logic to actually grasp? Turns out, the AI needed way fewer examples to master Borda compared to the others.
And that, right there, is what's so powerful about this. By using an AI not as some perfect genius, but as a student with a fresh set of eyes, we get this new magnifying glass to hold up to our own social systems, and we can suddenly see them from a totally different angle, revealing these hidden properties about their logic, their complexity, and maybe even their fairness.
And that really leaves us with one final, fascinating question to chew on. When a machine designed purely to find the most logical and efficient pattern finds one of our voting systems more natural than the others, what does that tell us about the very nature of that system itself? It's a thought that might just change how you look at the architecture of our choices.